Hi everybody, this is your lecture 11, part 3. So in this part, you're going to see how to calculate Spearman's rank correlation coefficient, and you will see how to interpret the calculated value of R. So in part 1, you have seen how to calculate the product moment correlation coefficient. So this is a different type of correlation coefficient. And when do we use it? For example, if we have two coffees, A and B, and we have 8 independent coffee tasters giving marks out of 10 for the two brands of coffee, how are you going to determine the correlation between the marks given by the 8 tasters? So in part 1, you have seen examples where as one variable increases, the other variable increases. That is, one variable is dependent on the other variable, or you may have a negative correlation like this. Yeah. So as one variable decreases, the other variable, as one variable increases, the other variable decreases, vice versa. Yeah. But here one variable is dependent on the other variable, that is y is dependent on x, but that's not the case here. Yeah. So how do you determine the correlation coefficient? How do you determine the relationship, correlation? How do you determine whether there is an association between the two variables? So this is where we have Spearman's rank correlation coefficient. When correlation on bivariate data is based on subjective rating or rankings, we use an alternative way to find the correlation coefficient, and that is Spearman's rank correlation coefficient. And this actually, it can be also be used on bivariate data where PMCC can be used. Okay. So now let's see how to do this. So if we want to see the correlation, what do? We first draw the scatter plot. So let's draw the scatter plot. Coffee A along the x-axis, coffee B along the y-axis. Remember guys, this is not the similar set of data, bivariate data, or like the one we did in part 1. Here, coffee B does not depend on coffee A, okay? So they are two completely different variables, okay? They do not depend on each other, yeah? So here we are just trying to find what is the correlation between the ranks, the marks of the two coffee, okay? There appears to be a positive correlation between the ratings of the 8 coffee tasters. So that is what we're going to do here, okay? We are trying to find whether there is an association or relation between the rankings or ratings of the 8 coffee tasters. Okay. So this Spearman's rank correlation coefficient will allow us to obtain the level of correlation. Okay, how are we going to do that? Yes. So what we do is, as the name suggests, we first have to rank the individual ratings for each variable. Okay, so what I do is I usually add an extra column on the side for the rank. For example, for coffee A, I just include an extra column for ranking. Similarly for ranking the coffee B. And then I arrange this in the ranking order. Yeah. So let's do it together now. Okay, we're going to do it together. Okay, so first, what do? We have to arrange the ranking for coffee A. So this coffee seems to have received the highest marks out of 10, that is 10 out of 10. Yeah. So I'm going to rank this as 1. So we'll have in rank 1, or the first position, you have the taster 6 who has given 10 out of 10 for coffee A. Yeah, so 10 marks. So this is your first. Then what's the next highest value or next highest score or marks? What's the next highest marks here? 9. So that's your rank 2. What's the next? 8. 8 is the next highest value. So you're going to rank 3. Oh, no, there is another 8. So you're going to rank 4. So what, although they are same, see 8 and 8, you have to follow the same process, and then you have to give a rank by averaging the two values. So for example, you have on the third rank, on the third position, you have 8. On the fourth position, you have 8. So that means they share the same position. So you take the average of the ranks. So 4 plus 3 divided by 2 is 3.5. And so you give the rank 3.5 for them. Okay. 3.5, 3.5. Got it? So the rank here is not 3 and not 4. It is 3.5, the average of the two ranks. So where values are tied, that is, if you have two values same, then you average the combined ranking. Okay. And one more important point, it doesn't matter whether we start with the highest or lowest value, as long as we rank both variables A and B with the same approach. Okay. So it doesn't matter. I can start here as from rank 10, then 9, 8, 7, 6, 5. But this is the most convenient way to do it, just the way how our brain works. Yeah. Okay. So after that, third and fourth position has been shared between these two. So now next will be 5. This is your fifth position, the next highest value. And then you have the next highest value here. And then what's the next highest value? Good. That's 5. And the next highest value? Good. That's 4. Similarly, we can do for coffee B. So I'm going to erase this. Yeah. Now we're going to do for coffee B. And you're going to help me. So that's your first highest value. So I give rank 1 to that. What is our second highest value? We have, there are 3 values which are same. So you have 8, 8, 8. What do? You follow the same process. So I would say that this is 2, this is 3, this is 4. And then I take the average of the combined ranking. So 2 plus 3 plus 4 divided by 3. So what is it? So average is 3. So you put for each of them it is 3. Okay, so the rank is going to be 3. Okay. Next, what do you do? What's the highest value, next highest value? Good, that's right. So what will you give? 5.5. Why? Because 2, 3, 4 has been taken by these values. The next highest value is 7. And look at that, 7. You have 2 7s. So the next highest value is taken 5, 6. So average of 5 and 6 is 5.5. So they get 5.5. The rank is 5.5. Yeah. So they share the rank. They share the same position. Yeah. The next will be 6. So it's going to be 7, 7, and 8. So you do the same way, 7 and 8, and then take the average. Okay, so that's how you arrange the order of the rank from the highest value to the lowest value. Okay. Okay, once you've done that, once you have ranked the two variables, You calculate the Spearman's rank correlation coefficient using this formula. Just as we have seen in part 1, the correlation coefficient, the R value, here we call this as rho. Yeah, rho is equal to 1 minus 6 times sigma d square over n times n square minus 1, where n is the number of tasters here. Yeah, so we have n is equal to 8 here, and D is the difference between the two ranking, that is 7 minus 7.5, 3.5 minus 3, 6 minus 5.5, and so on. And when you say sigma, you find the difference, square it, and sum it up. Okay. So just like I mentioned in the first week, the R value, which is rho here, the Spearman's rank coefficient, should lie in the scale between -1 to 0 to 1. Yeah, it should lie between -1 to 1. Okay, the correlation is either perfect positive correlation or perfect negative correlation or anywhere in between the two. It could be anything, yeah? So that's what you're going to use rho to calculate. That is, you're going to use this formula to find if there is a correlation between the two variables. Okay, so what I do is I simply add 2 extra columns here. So one for D and then one for D square. That's what I've done here. That makes it easy. Yeah? So first I find the difference between 7 and 7.5. What is the difference between 7 and 7.5? 0.5. Yeah. So I calculate the distance. Rank A minus rank B. It's all right if you do the other way. Doesn't matter because it's a square, so the negative sign disappears. Yeah. Okay. So 7 minus 7.5 is 0. Minus 0.5. Similarly, 3.5 minus 3 is good. 0.5. 6 minus 5.5 is 0.5. 2 minus 1 is 1. So look at that. Here, there is one more important thing you have to see, okay? So when the difference between the ranking is almost 0, so what happens is this part becomes 0. The difference between the ranking is 0. That means rho is almost equal to 1. Yeah. So the closer the rankings are, the stronger the correlation between the markings. Yeah. Okay, that's very important. Yeah. So as D increases, the difference between the two ranking increases, rho gets away from the perfect or the perfect correlation. Yeah. That means the strength of the correlation decreases. Yeah. Okay. So now as you go, see 8 minus 7.5, 0.5, and so on, you can calculate the difference. Once you do that, you start calculating D square. That is, you just square each of them, square them. So 0.25, what is the square of this? 0.25, good. What is the square of this? 0.25, and so you calculate each one of them and then find the sum total of all the D square value because you have to find the sigma D square. So can you use your calculator and find the value of sigma D square? Good. And you get 14. Yeah. So now you substitute that in this formula. You have 14 square and n is 8. Yeah. So you substitute all the values and calculate the rho. What is rho? Please calculate and type it down there. Very good. And you get 0.833. So this shows that, what does this value say? Where does it lie? between -1, 0, and 1. It is a positive value, isn't it? It is a positive value. So that means the correlation is positive, just like how we saw in the scatter plot. Yeah, but we didn't know what the value of the correlation was. So that is why we are using Spearman's rank correlation coefficient to find the value of the correlation, to find the strength of the correlation. We know that it looks like there is a positive correlation, but what is the strength of the correlation? Now we have certain value to say that, yes, the correlation coefficient is 0.833. So we can say that the strength of the correlation is strong positive correlation is 0.833. Okay, so Spearman's rank correlation coefficient is more general than PMCC and is usually less accurate. Because why? Because you're actually here using ranks rather than the data itself to find the correlation coefficient. Okay, so what would happen now? I have a question for you guys. What would happen to the value of R if the taster 4 rated coffee B as 10? Okay, so instead of 9, the taster has rated it as, the score is 10 now. Okay, what would happen to the value of R? Good, there is no change because the rank is still 1. So look at that. Because it depends on the rank, not the data, there is no change in the correlation. So that is why this is less accurate. It just gives you, it's more general than PMCC, isn't it? So the answer is no change. Good. Because change in value does not affect the R value since it has not changed the ranking. Because the row value, the correlation coefficient, Spearman's rank coefficient depends on the rank rather than the data itself. Okay, so that's all in part 2. So we have seen how to calculate Spearman ranks correlation coefficient using the formula, and we know how to interpret R if you change any data value. Yeah, because it depends only on the rank. Okay, that's all for now. Thank you.